Hi everybody. I know you guys are probably so excited. This is our last week of genetics. We're going to be talking about multiple alleles. Specifically, we're talking about the ABO blood types, and then we're going to be talking about pedigrees. With multiple alleles, there are many genes that have more than just 2 alleles for a trait. Along with having multiple alleles, a gene may also show incomplete or codominance, which we talked about. So with the ABO blood types, you're going to see multiple alleles. So there's actually 3 alleles possible for blood typing. They represent it as IA, IB, and then little I. You guys can just say, and you can write A for IA, just B for IB, and then little I you can put O, because O's are genotypes of different people. So with type A, you can either be homozygous or you can have the heterozygous form. So instead of using these I's, you can just write AA for somebody that's homozygous type A blood, AO for somebody that's heterozygous. Same thing with type B. You can either be homozygous form, which is capital B, capital B. Remember, homozygous means the same, so it's 2 of the same letters. And then BO would be the heterozygous form because it's different. For O is recessive, so instead of writing little i's, you guys can just write OO for somebody that is type O blood. And then type AB, instead of writing IAIB, you can just write AB. So these would be the genotypes right here that you would use in your Punnett squares for the different individuals. So again, the blood types show multiple alleles because there's more than just 2 alleles. We were just used to like a capital T, lowercase t. Now you can either have an A, B, or O, and you always have 2 of them because you get 1 from each parent. Now, blood type also shows codominance because if you have AB blood, you have both A and B together. So they're both dominant together, and they're always dominant over O. Now, you guys may have heard about positive and negative. That is another allele, and it's actually an antigen that you would see on your red blood cells. So we're just going to stick with like what type of blood you have, A, B, O, or AB. We're not going to put the pluses and the minuses on it. So here's an example of a Punnett square. So it's a monohybrid still, so that's a 4-box Punnett square because we're just dealing with one trait. We're just dealing with blood type. So it says cross a person who is homozygous for blood type A. So remember, blood type A can either be the homozygous form or the heterozygous form. They want the homozygous form. So that would be capital A, capital A. So that's homozygous for A blood. Then they want to cross it with a person that's O. So here's O, just OO. Okay, you put them together. It would ask for the genotypic ratio. So this would be 4AO to 0. So remember, genotypic ratio is the letter combination. So that would be these. How many of AOs do you have? Phenotypic ratio. This would be what type of blood does this person, these children have. So it would be 4 type A blood to 0. Now it says probability. What's the probability of having type O? Well, if it was type O, the child would have to have OO in there. So none of them. So it would be 0% or 0 out of 4. So there's many more video tutorials on how to do more examples of Punnett squares with blood types. So make sure you guys review those, watch them before doing the worksheet. So what does your blood type actually mean? It has to do with a protein on the surface of your red blood cells. So for example, if you have blood type A, you have what's called an antigen A on the red blood cells. Okay, so this is the protein. It's called an antigen. If you have blood type B, you have B antigen on the surface. If you have AB, you have both A and B antigens on the surface. And then if you have blood type O, you have no antigens. So it's extremely important for like nurses and doctors to figure out what blood type a person has because maybe you're in an accident and you need blood. That's called a blood transfusion. So you need to get blood from people. That's why it's important to donate your blood. So AB individuals are known as the universal recipient, which means they can get blood from any of the types of blood. The O, you guys are special if you have type O blood because you're the universal donor. You can give blood to any of the other blood types, but the problem is with you guys is that you can only receive O blood. Okay, so if you're blood type A, you can receive A or O because O is the universal donor. If you have type B blood, you can get it from B or O people. Again, type AB is the universal recipient, which means you can get it from any type of blood. And then O, you can only receive O blood. So the next topic this week is pedigrees. So we're just doing simple pedigrees. So a pedigree is like a family tree, except it's going to trace a trait that we're talking about. So maybe we're talking about dimples in a family, or freckles, or maybe we're talking about like diseases like hemophilia. So the symbols, you're going to see squares stand for males, circles are females. If you see a line between a square and a circle, a male and a female, that means these two individuals are married, okay? With the line coming down, that these individuals then would represent the children of these people. If you see a fully shaded in square or circle, that means this individual has the trait, okay? Some pedigrees that you will see, you'll see half shaded. Half shaded means that they're carriers. Okay, so they may not have the trait, but they have one allele for it. Just like when we talked about sex-linked, when we talked about hemophilia or color blindness, the females, they're normal, but they may have one allele that they pass on to their children. Okay. Now, when you're interpreting pedigrees, the first thing we want to know is the trait autosomal or sex-linked? So autosomal, remember, means it's not on the sex chromosome, specifically not on the X sex chromosome. So that means it's on any of the other 44 autosomes. If it's sex-linked, that means it's on the X sex chromosome. So that's what we talked about, color blindness, and we talked about hemophilia. So the way that you can tell if it's autosomal or sex-linked is if most affected individuals are the males, then it's most likely X-linked. So if you see more males than females, it's X-linked or sex-linked. If you see like a 50-50 split between males and females, then it's most likely autosomal. So then that's the first thing you got to figure out. Is it autosomal or sex-linked? Because if you were writing the genotypes, autosomal would be like normal. It would be like big D, little d, or big D, big D. But if you were writing the genotype for sex-linked, you would have to have the X and the Y and then put the alleles on the X's, just like we did last week with the sex-linked worksheet. Now, the next thing you need to do is it dominant or is it recessive? So if it is a dominant trait, one parent must have the trait, and it will most likely be seen in every generation. If it's recessive, neither parent may have it, and you'll see it skips generations. So you'll see like no parent has it, like the male and the female parent don't have it, but then they have a kid that does. So that means it's recessive. So that's when you would use lowercase letters. So let's just look at this pedigree and let's interpret it. So again, males are squares, females are circles. This means these two individuals are married. And then the line going down, that means these two are the children. And if you look at this, this means this male married in and this female married in. Okay? So on the side, you'll see the generations. So this is generation 1, 2, 3, 4. So this pedigree has 4 generations. Maybe another question you have is like, how many females are there in this pedigree? So you would count up all the circles. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So you would say there's 9 females. Maybe they ask you how many individuals have the trait. Well, remember, to have the trait are the completely shaded in. So you would have 1, 2, 3. So that would be 3 males have the trait. Okay, so then maybe they're going to ask you, well, what's the relationship between this number 1 male and up here in the original female? Okay, so if you look at it, this is the original female, this is her son, and this is his son. So this individual would be the grandson of her. Okay, so those are just some questions that you may ask. Maybe it says like, what does number 1 have in common with number 3? Okay, well, they're cousins. Okay, so these are the types of questions that you may be asked. Okay, so then we have to go back to the autosomal sex-linked question. So again, if it's autosomal, it's going to be a 50-50 split between males and females that have the trait. So you're looking for the shaded in people. If it's sex-linked, there's going to be more males. So if we look here, only males have it. So that means this trait is going to be sex-linked. So if I had to go back and find everybody's genotype in this whole pedigree, I would have to put XX for the females, XYs for all the males, and then I would have to put the alleles on either capital or lowercase on the X's. But we're not going to ask you guys to do that. We're just going to keep it real simple. So then the next thing you have to do is it dominant or recessive? So if it's dominant, at least one parent has to have it, and you should see it in every generation. If it's recessive, two parents cannot have the trait, and then a kid does. So then it would skip generations. So you can see here, these two parents at the top here, so right here, they do not have the trait, but their son does. Same thing here. These two parents don't have it, but a son does. So it actually skipped this whole generation. So in this case, this would be a recessive trait. So overall, this would be sex-linked and recessive. Okay, so let's interpret this pedigree. So again, how many generations would there be? There's 1, 2, 3. And a lot of times you guys will see that on the side as Roman numerals. So then, for example, these two parents, how many children do they have? Well, they have 1, 2, 3. They have three children. This 4 wouldn't count because she actually is married in. So then maybe it's like, how many grandchildren does individuals 1 and 2 in the first generation have? How many grandchildren? You would say 1, 2, 3, 4, 5, 6. They have 6 grandchildren. All right, so then the next thing you want to do is, again, is it autosomal or sex-linked? So you have to go back to your original rules. So make sure you guys keep going back to that original slide. So if it's autosomal, it's a 50-50 split, or really close to a 50-50 split between males and females that have the trait. If it's sex-linked, it's mostly males. So in this case, we have 1, 2, 3 females that have it, and we also have 3 males. So that's close to that's a 50-50 split. So that means this trait would be autosomal. So you would just use normal letters if you were finding the genotypes. You wouldn't need to use the XX and XYs in your genotype. So then the next question is it dominant or recessive? So again, dominant. You're going to see it in every generation, and at least one parent has it if they have a child that has the trait. Recessive, it'll skip generations, and you'll see 2 parents that don't have it, but then they have a kid that has it. So if we go by those rules, notice how every single parent that has children that have the trait, at least one parent has it. So look, this parent has it to this person. This person, oh, they have children then that have it. Same thing here, you have a mother that has it and then a son that has it. And you see it in every single generation. So in this case, this would be a dominant trait. So in this case, it would be autosomal dominant. So maybe we ask you, give us the genotype of parent in generation 1, number 2. So this female. So again, because it's autosomal, you don't have to write like XX for the female. You just have to use the letter combinations. So again, it's dominant. So we're going to use a capital letter. And then having no trait would be little d, little d. Remember, you have 2 alleles. So it would have to be little d, because if it had a capital letter, it would overpower the recessive. So if you look at this pedigree, every single person that's not shaded in would have a genotype of little d, little d. So again, if we just wanted to know this female's genotype, we already know her husband's little d because he doesn't have the trait. So we need to figure out what she is. We know she's dominant and she has the trait, but is she big D, like homozygous? Or is she heterozygous, big D, little d? So what you would have to do is you would have to look at her children. Notice how this female child, she's little d. So she's going to get a little d from her dad, which means she has to get the other little d from her mom. So this genotype would be big D, little d. So she would be a carrier and heterozygous. So again, you guys can see this female would have the big D, little d genotype. So you could potentially go back and do this for every single person and find every single person's genotype, okay? We're not going to ask you to do that though, but that's what you could potentially do. If you guys have any questions, please reach out to us.